Pre-trained programming, data science, and artificial intelligence. This is week number 6. And in week number 6 is a continuation of what we covered so far. Unfortunately, for week number 5, we had some technical issues, and there is no recording for week number 5, session number 2. It was data visualization. So today what we are going to do, we are going to go through what we covered in week number 5 very quick. Then we are going to jump into data preparation and preprocessing 1. For data preparation, data preprocessing, I know we need more than a session. We need at least 5 or 6 sessions to cover everything. But unfortunately, we are going to cover only a few things. And it is your responsibility to carry on and do some research and learn other techniques that we might not be able to cover during this free program. So we are still working for this our insurance company, and our job is to help the business determine the solution for the money loss because of the fraudulent. So you've been hired as a scientist, and you've been challenged with the business problem that says, in spite of having a fraud investigation team that investigate up to 30% of all claims made, we are still losing too much money due to the fraudulent claims. So that is the problem statement. In few sessions earlier, we learned how to frame this problem. We learned how to build a bank of questions, descriptive questions, predictive questions, diagnostic questions, and prescriptive questions. And then we had a chance to look into the data. So this is the data that we have. So far it's 1,000 claims and 1,000 accident, 1,000 claims, and this data comes with 39 features. And this data was pulled, was generated, was taken from different, I would say, different departments or different domains. So we got, if you were to look into this data, we got some data from the client. This is client, customers. We got some data from policy number, policy. So this is all different domain. We got some data from the finance. We got some data again from the client, about the clients. Then we got some data from the incident, from the claim domain. And then we got some data about the cars, about the involved, etc. Then we got our target variable. So in the previous sessions, we learned how to reduce the dimensionality of our data using either what we call prior knowledge, where we normally should eliminate any features that we know for sure they won't bring any value to the analysis. So we could eliminate IDs, we could eliminate dates, unless we planning to do time series analysis. We eliminate any constant features. We eliminate two personal information features. We eliminate the high hierarchical or high hierarchy, high cardinal features. So these are some of the techniques that we could use right in the fly to eliminate some of the features. Also, we learned how to eliminate features by using correlation analysis. We eliminate features that they are very weak, they don't have any correlation with the target variable, and we also eliminate features that they are highly correlated with one another to avoid what we call multicollinearity. So we are going to continue visualizing this data, just exploring it. There are more than three methods that you could use to help you understand data better. You could use exploratory data analysis, and you could use the data visualization. You could use the descriptive analytics or statistical analysis. There are many methods that you could use to help you understand the data. And understanding data is crucial. Understanding the business is similar, is in the same level of importance as understanding the business. If you don't understand the business problem, you are going to have problems solving it. If you don't understand the data, you are going to have problems using it. So these two parts of the entire analytical project, they are crucial. They are time consuming, so it does require a lot of effort, a lot of investigation, a lot of requirement gathering, a lot of work. So don't panic if you feel like you are spending too much time on these two parts. That is, if that is the case, then definitely you are doing all right. If you feel like if you just started in a project and you jump straight to modeling and solution design, then you are doing something wrong. Okay, we are going to fire up the Jupyter notebook. So we will go through very quick. We are going to go through what we covered. We are going to go through what we covered so far. So we are going to go through the same file, which you already have access to. Okay, so I'm going to go through very quick because we need to move on to the next, to week number 6. So the first thing we gotta do is import all the libraries we are going to do. We are going to need Numpy, Matplotlib, Pandas, and the Seaboard. And if you are going to have some, always we are going to have compatibility issues. So if there is going to be, and these compatible issues, they are going to throw some warnings, which is going to be, of course, space consuming, or sometimes they are going to be ignoring. They are going to be a headache. So we could ignore them right from the beginning. So I'm going to run this. Okay, it should not take this long, but for a reason it is. Okay, great, and now we are going to read our data. Then we are going to clean the names using the generator. We are going to use the generator to clean the names. Why do we need to do that? We talked about this several times, is to avoid having some discrepancies, contradictions, and name-conventional issues with the features. So for example, we have age, capital A, transformed to a lowercase a. We got here capital minus loss, transformed to capital underscore loss. The same applies for capital minus gains. Now we got it capital underscore gains. So there are a few NumPy generic functions you could use: mean, standard deviation, var, PTP, square, minimum, maximum. You could always use as many generic functions to help you understand the data better. So we talked about the info function that provides the information about your data, missing values, the type of the data. This info will definitely determine how much effort you are going to need. And if we were to look into this information, we got 1,000 entries, and luckily we got 1,000 entries per feature. That simply means we don't have any missing values, but we have a lot of categorical data. We've got a lot of categorical data that we need to transform later. And to transform this data, this categorical data in numerical data, we need to determine if this categorical data is nominal or ordinal. And the reason why we need to do that is to avoid duplication and to avoid creating some biases. Then we talked about the describe that provides the statistical analysis of the 5-number summary of your data. You are going to get information on the minimum, the maximum, and the quartiles. Of course, some extra information, count, mean, and standard deviation. And this describe by default works for numerical data, but if you were to force it to include the categorical data, you simply add include object, comma, let's say boolean, if there is going to be a boolean, if you have boolean, comma, whatever character. If you are not using pandas, then you are not going to see, you are going to have different type of categorical data. Then we talked about our target variable, which is very important. And target variable is, we got out of 1,000 features, out of 1,000 claims that we have, we find out that 75%, almost 75% of these claims, they are legitimate. Means nothing when they were legitimate, they were done correctly, they were real accidents, and 25% of the claims they were fraudulent. Means that the business has lost a lot of money paying off this 25% of the incidents. They were not a real incident. Someone broke their car just to get rid of it and get refinanced or get reimbursed. So it happened a lot. So, and this is what we need to find out. So to determine how to predict the future of this problem, then the first thing we gotta do here is we need to find out the mathematical relationships between the fraudulent, between all factors that would lead to claims to be fraudulent or legitimate. This simply numbers, and there is a math, chemistry, there is a math signals, there is a math hidden relationships that we need to discover later using algorithms. So we need to determine if a future claim is going to be either legitimate or fraudulent. And this is what we call this value here. This is what we call the dummy model, or simply is called the base model. So we are going to, whatever model we are going to create in the future, it is going to be compared to what we have in the data. So this number here, 75%, 25%, is a number that we can use to guess, just a guess. So if anyone calls in at this point of time to report a claim, we could simply say that claim is 75% legitimate, and we could be wrong 25%. So if we were to guess, we are going to use the base or what we have already in the data. And but this is not what the business has invested in you, has brought you in as data scientists. So the business has brought you in as data scientists to have a better values than guessing. If I were to guess, I don't need you. I need something better than guessing. So we want to reduce these values. Okay, so that is our target variable. Then we learned about the some visualization, and in terms of visualization, of course, there are many graphs that you could use. But the most common graphs, and we talked about this several times, is number one, bar plots, which are used to visualize the categorical data and compare the elements of the categorical data. We could use box plot to measure the distribution of your data. I'm sorry, the position of the data, and also it helps understand some of the outliers, detect some outliers. Then we could use density plot to help us understand how dense or how sparse your data is. We could use histogram. It's to visualize the continuation or the values or the numerical data, digital data. We could use a line plot for time series analysis and for connecting the dots. Then we could also use scar plot to visualize the relationships between 2 plus independent numerical data. It's used only for numerical data. And of course we could use other techniques, but these are the most common graphs that you could start with. To help you understand the data better. You could feel free to try others. It totally depends on the data you are working on, and also it depends on the type of problems you are working on. But feel free to try as many as you can. Now, your job as data scientist is to keep trying until you find something meaningful. Don't limit yourself to these 5, 6, 7 most common graphs. That might not be the case for all the time. So just visualize the few features, the age, the month as a customer, and age, and in terms of the distribution, we got some problems in there. They are not 100% normally distributed. They are not bell-shaped. They are not Gaussian distributed. So we might need to tweak them later. We got few features that are really skewed. So this is highly skewed to the left. This is skewed to the right. That simply means if you were to use these two features, we need to do something about it. Otherwise, most likely it's going to create some problems related to a bias. So a bias, it is one of the hidden enemy for data scientists. Your enemy is a bias, and the bias, unfortunately, it's always going to be there. But your job as data scientist is to try to reduce it as much as you can. Leaving a bias in the data, it is going to definitely create some bias at the end result. So most of these algorithms that we are going to use later, they have some assumptions, they have some conditions that they were designed for, or they were designed with, that would help to reduce the amount of bias in the data. And one of the most common assumptions made or these algorithms designed for is the normality. Most of the algorithms, they assume that your data is normally distributed. Means, hey, someone stop playing with my keyboard, otherwise you are going to be kicked out. So please stop playing with with my presentation. Please don't do that. Thank you. So you see, guys, disturbing me, and that's not really fair. حرام عليك يا أخي هذا اللي كيلعب screen. Please don't do that. Okay. So again, I know the bias is your enemy. Your job is to try to fight or reduce the amount of bias in your data. And as I said, one of the most common assumptions that you need to have in your data is normality. Your data has to be normally distributed. That simply means the skewness has to be zero. The skewness has to be zero. Then we looked into few density of few variables. So we are comparing so when we did the what do you call it, the histogram for the age and customer, you simply see how normally distributed these two features, but we don't understand, we are not yet understanding the relationship between them. The density plot is way more advanced. It provides more information than the histograms. It does provide the skewness and also the similarity. So if you were to look into the this is age and the month as a customer, they basically have the same pattern. That simply means most likely they have the same information. They carry the same signal. They carry the same value. So we have to get rid of one of them. And most likely they are highly correlated. Age and month as a customer, they are highly correlated. We can tell just before we go further and discover this. So we can tell that they are highly correlated, and we have to eliminate one of them. Which one? This is something that we are going to learn later. Okay, then we talked about the visualizing the categorical data, and we looked into comparing. Comparing the policy states and incident states. We find out that few states, probably 97% of incidents have been claimed outside the state where the insurance policies been dictated or been issued. And this is a very good insight, and with this insight we could enforce, simply we are going to educate the business about this insight, that probably out of this, probably 97% of all claims, they are outside the state. So simply means these drivers, they are traveling. So can we increase? One way to generate some money for the business is increase the premium for anyone driving maybe 70 miles plus. You could lie, but if you call to report a claim, and we find out that you've been driving more than what you signed for, then definitely it is going to be an issue. But this is a beautiful insight that you could share with the business to generate more revenue, and also to decrease the amount of claims that being reported outside of the insurance issued states. Okay, now let's compare the educational level and relation. Yeah, I don't see anything that is worth investigating further. But again, your job is to keep trying you could switch, just play with the values and see if you can find anything that is meaningful. We are going to compare insured sex and incident states. So there is another insight here. As you see, we have more female calling to report claims than male. Is this an insight? Yes, there is an insight in there, but what do you think we should do? What do you think we should do? Yes, I mean هما كيديروا حوايج بزاف ولكن اشنو هو اللي خصنا نديرو now as a company يعني our female drivers
he claims a lot.
إلى طلعتي مثلا إلى الرجال كيخلصوا 100 درهم، العائلات كيخلصوا، النساء كيخلصوا 200 درهم، ما يعرفش يبغيو. that is discrimination. That is discrimination. Of course إلا كنت أنا مرأة وشرجيتيني في 400 درهم مثلا وراجلي ولا خويا شريتي لي 200 درهم, I'm not going to be happy. That is discrimination. Someone, you could do it in Morocco. I think you could do it, but in US I don't think you'll be able to do it, because you are going to end up discriminating your clients based on the gender. Yeah, it's good to know that we have facts that we have more incidents from the female sides versus male, but I don't think we can do anything. I really don't think. خصنا نشوفوا شي محامي هو اللي غادي يعطينا خلاصة ولا يقرر لنا واش ممكن ناخذوا إجراءات ضد يعني ضد النساء. Sorry guys, let me fix my camera. ممكن ولكن خصك تكون you have to be careful. في أمريكا تقدر أي أخت تقدر تديك المحكمة. You could. Okay, I'm just saying, but you need to be very careful. Okay, you cannot simply make a decisions based on ethnicity, based on religion, based on gender, based on political views, etc. You cannot do that. Okay. Okay, just play around, changing these figures and values to see if you are going to get is the same. We are going to get any difference. Okay, so we covered the numerical data, basic numerical data visualization, basic categorical data visualization. We could create a multivariate visualization. But before we do that, let's talk about the correlation analysis. And a few weeks ago, we talked about the correlation in a helicopter view. So the value of correlation analysis is always going to be between -1 and 1. And of course, we are going to have a 0 in there. So in this correlation analysis, we are looking for the correlation between X and Y and X and another X. Of course, we are going to have X and itself. So the correlation between X and Y should always be the best. The best features is the features that they have strong correlation between X and Y. Strong, that means they have a strong correlation, either positive correlation or negative correlation. For this is X and Y. X and X is the opposite. we are going to keep features with very low correlation. Okay, so X and Y, anything that is in the yellow area, we are going to keep, and we are going to remove anything in the green. And X and X, we are going to remove anything in the yellow area and keep only the green. And yes.
I don't really understand. How can we compare, for example, X and X, something with itself? I don't really get that. Can you please?
Do you know X and X means X is all these inputs. So for example, this is X1, this is X2, 3, 4, 5, all the way to the end. So we are going to find the correlation between month as a customer as X1 and age as X2. And if they have a value closer to 0, then we are going to leave them. If the value of this correlation is greater than 0, then we need to determine which one to keep based on how closer this value to -1 or 1.
We speak about 6,
Abdeladim, I barely hear you.
Okay.
كان شي مشكل في الصوت يا أخي ما كنسمعكش مزيان.
Now it's okay?
Yeah, Gary, try again.
Okay, I will try. Now it's okay?
Yes, now it's better, yes.
Okay, I'm sorry. I just using my headphones. So I'm telling when we speak about X and X, it means X1 and X2.
Yes.
It's not the same X.
No. I'm not saying the same X. My apologies. When we talk about X here, we are talking about different inputs.
Yes, that's why we are confused.
Yes, it's different inputs.
Thank you.
You're welcome.
Okay, thank you.
Okay, so there are a few conditions for to get better insights from this correlation. There are a few conditions: 1, 2, 3, and 4. So the condition is the features should be numeric. The correlation analysis does not work for categorical. Okay, it should be pair. Pair means إذا عندك مثلا في هذا عندك 1000 you have 1000 we have to have 1000 ما تقدرش دير correlation مع X1 and X2 X1 في 500 records or X2 في 3000 records, so they have to be 3000 3000 500 500. That is called pair. So you have to have a pair to apply correlation. Number 2, they have to be normally distributed. And number 4 means you still can apply correlation for non-normally distributed features, but the value that you are gonna get is not gonna tell you the truth. The value is gonna be biased. And number 4, which is very important, you have to have real values. So what do we mean by real values? So for example, if we were to transform this male to numeric, just an example. So we are going to give 1 to male and 2 to female. So we are going to get 1, 1, 2, 1, etc. So these are not real values. They were transformer values. They were transformed from categorical. Can we still do correlation for transformed values? Yes, we can, but they will not tell you the reality. So you are going to get the values, but they are not going to do. They are not going to tell you a reality. So that is why it's always good. It's always good to apply correlation analysis before you transform categorical data to numerical data. Yes, sir.
What about normal distribution?
Yeah,
General use.
Abdul
What
Azim,
is?
I barely hear you. Can you please type in your question?
Okay, okay, thank you.
كان عندك مشكلة في الصوت يا أخي ما كان سمعكش مزيان. Yeah, so please do that. Okay, and for the correlation, there are three correlations. We got Spearman, Kendall, and Pearson. All of them, they are doing the same things, but they are measuring different type of relationships within your data. Some of them they are measuring the association. Some of them they are measuring the influence. I don't. Anyway, these three type of correlation, they measure different type of relationships between elements. Normally distributed data is a data that looks like bell shape. This is called the bell shape. Is also called Gaussian distribution and normally distribution. There's a few names. If you have a data that looks like this, this is skewed to the right and the opposite is skewed to the left. So this is not good data, this is a good data, and this is something that you need to apply to your data. Your data has to be normally distributed. So looking into our numerical data, so this is not normally distributed, so they're going to be good for correlation. You are still going to get correlation values out of these features, but the correlation, the values that you are going to get, they might not tell you the truth. They might not tell you the reality of the relationship between these features. So you have to be careful. So let's apply correlation analysis very quick. So correlation is simply use the .core method. So .core method, this is the method we are going to use. Here we go. Now let's take a look. The first thing we are going to find out is the correlation with the target variable. So we got 0.020, minus 0.09, minus 0. They are very, very minimum, very close. This correlation, they are very close to 0. Yeah, this one is very minimum, very small, 0.07, and this one is, so our year has to be removed. Yeah, our year has to be removed, and there is another one. Yeah, 0.04. Incident hour of the day. So on the top of the features that we already know that they should be eliminated because of the prior knowledge. Yeah, we are going to remove our year and incident hours of the day, because the correlation between these two features and the target variable is very, very, very minimal. So it is somewhere closer to 0. So I don't think there is going to be any issue removing them, because they don't have any influence with the target variable. Okay, and now we need to look for the correlation. That is correlation between x. This is correlation between x and the y. X means an input, and the y means the output. So now we need to look we need to look for correlation between x and different x. And in the correlation between x and different x, we need to avoid any correlation, any value that is closer to +1 and -1. Let's take a look. Do we have any high values? And most of these values, they are very small. And we saw 22%, 27, 26, probably a little bit higher. Yeah, we got few. 98, this is highly correlated. 72, highly correlated. 73, 81. Yeah, we got some features that they hardly correlated. 92. But as you see, you know, going through these values is really pain. So what we need to do, maybe we could transform this correlation into heat map, into a graph. It's called heat. It's called heat map. I think I have it somewhere. I have it somewhere in there. So let's just visualize this very quick. Yes, this is heat map. Okay, let's take a look. So just looking into this heat map, which simply capture color-wise, it capture the relationship between these features. We can tell there is something wrong. There is something wrong between month as a customer and age. So there is a highly correlation between month as a customer and age, which we already determined using the density plot. فاش لقينا فاش درنا density, we notice there is something, there is كاين تشابه، كاين واحد تشابه ما بين density ديال age و density ديال month as a customer. There is a similarity. And that similarity is simply what we find there is a highly correlation. Okay, so Bushra, I'm sorry sir, I still have a problem with the correlation between x and x and y, where the difference is, since the x are different in the first. So x means all inputs. Y is your target variable. Okay, Bushra, clear? Bushra, are you clear? Yes or no? So x هما هاد الخضرين كاملين، هاد الزرقين. the y هاد الخضر هذا. So اشنو هي العلاقة الرياضية المخفية ما بين our model and our year؟ كاين واحد العلاقة رياضية مخفية بيناتهم. هذيك العلاقة ما خصهاش تكون قريبة لواحد ولا قريبة لناقص واحد. it has not to be it cannot be إلا كانت قريبة لواحد ولا قريبة لماينس واحد كتعني عندهم واحد العلاقة قوية، عندهم واحد التشابه، كتعني بأن راه عندهم نفس المعلومات، كتعني بأن إلا خليناهم بجوج غادي يخلقوا لنا مشكل في البايس. يعني إلا كانت العلاقة قوية ما بين هاد الزرقين بعضياتهم، يعني خصنا نحيدو شي واحد فيهم ونخلي شي واحد فيهم. مثلا نعطيك غير اكزامبل، مثلا عندك واحد اختك توام، انت اختك توام، يعني she has the same characteristic، كتشبه لك تماما، كتعامل بالطريقه اللي كتعاملي بها، كتهضر بالطريقه اللي كتهضري بها، كتلبس بالطريقه اللي كتلبسي بها انت، وبغينا شي واحد من عائلتكم يدير مثلا يعني شي واحد يمثلكم من عائلتكم، ماشي بالضروره الى مثلتو جوج اخوات، مثلتو غير اخت وحده تقدر تمثل العائله. اما الا جبتي انت اختك يعني راه كتمثلوا جوج خطرات. you are presenting twice your family, so you are providing duplicate information، كتعطيونا معلومات اللي هي duplicate. So that is simply means you are going to create a lot of confusions to the model, a lot of bias to the model. So إلا كانت العلاقة، إلا كان واحد التشابه اللي هو قريب ل 100% بينكم وبين شي شخص، راه غير شخص واحد يقدر يمثلكم. أما إلا كنتم مختلفين بغيناكم بجوج، إلا كنتم كتشابهوا بغينا غير واحد. بشرى clear?
Sir?
Yes, please
hold on. Can you hear me?
Yes, Bashra, yes, I hear you.
Thank you so much. That's what I know about correlation. But the problem that I have, correlation between X and Y must be not zero or.
Yes, that's what I said. No, yes, if the correlation between R year and fraud is closer to zero, that simply means R year does not have any mathematical influence. Literally speaking, it does not have any influence, so we need to remove the R year from the data.
Okay, sir. Thank you so much.
Okay.
I understand.
إلا كان
Thank you.
يا ويلكم. إلا كان احنا اش غادي نديرو دابا؟ غادي نخليو اي حاجه زرقاء اللي عندها واحد الانفلونس، واحد التاثير رياضي على الواي. الا ما كاينش تاثير ما غاديش نخليوك. هذه بخصوص العلاقه ما بين x and y. So for the relationship between x and y, x means any input and the y means the target variable. We are going to keep only the features, we are going to keep only x's that they have a kind of influence with the target variable. هذه x and y. أما x and some x إلا كان واحد التشابه ما غاديش نهزوهم بجوج، غادي نهزو غير واحد فيهم خصو يمشي. So I repeat, when we are looking for correlation between input versus output, we are looking for correlation that is not zero. يعني بغينا correlation يكون إما قريب لواحد أو قريب لماينس واحد. That's input and output. For the correlation between input versus another input, we are going to keep not closer to 1 and minus 1. يعني هذه correlation between minus 1 and 1 غادي نحيدو. we are going to eliminate anything that is closer to 1 and anything closer to 0, and we are going to keep anything closer to 0. اوكي. في الاولاني غادي نحيدو اي حاجه قريبه لزيرو. and we are going to keep anything greater than 0 or less than 0. في الآخر the opposite. Okay, Bushra, are you clear?
Yes, sir. Thank you so much.
Sure. Now let's take a look into Mahdi. We could calculate the scores at each input x by dividing the correlation between x and y by the sum of the correlation. علاش أخويا غادي دير قاعد يعني this is very complicated. Why do you need to do that? Simply we have a very simplest way to do it. You know, why do you need this is complicated, a lot of math, a lot of you could do it, but there is a lot of effort in there. Okay, we don't need to expert. Do we need to expert domain knowledge? Confirm. Yeah, always you are gonna need to work with the domain experts. Yes, you always need to do that. This is very good point. Always need to get your team involved. ودابا باقي ما هضرناش حنا واش غادي نحيدو ولا ما نحيدو، غير هضرنا على we know what to remove. دابا عندنا واحد list ديال features that we need to remove. Do we need to move them? That's something that you need to talk with the team. Okay, so عندنا شي مشاكل هنا في الاريا هذه، ولكن this is a very weird. This is a very weird area. اش كاين هنا؟ عندنا total claim, injury claim, property claim, vehicle claim. مع من؟ مع total claim, vehicle claim, property claim, and vehicle claim. يعني out of these four عندنا 4 هنا، خصنا نخليو غير واحد فيهم. شكون هو اللي خصنا نخليو؟ is the one with دابا منين كنلقاو في x and x x and x إلا لقينا شي حاجة اللي هي يعني لقينا شي حاجة اللي هي قريبة لواحد وقريبة closer to 1 or closer to -1, then we need to keep one and remove we need to keep one and remove the other one. So which one do we need to keep? For example, we find out there is a strong correlation between month as a customer and age. So one of them should be kept, one of them should be removed. Which one to keep? Now we need to go to the correlation between x and y. Okay, so we know that x and month as a customer, they are highly correlated. So month as a customer highly correlated. You see 92%. So now let's go to their relationship with the target variable. So month as a customer is 0.02 correlated with the target variable, and the age is 0.012. So which one do you think we should keep?
Month as customer.
Yes, we should. We are going to keep month as a customer. So we need to get rid of age, but of course, it's always good, as someone in the chat mentioned already, that we need to communicate this with our domain expert before we make a decision. The other ones is total claim amount, injury claim, property claim, and vehicle claim. We got 4 elements. They are highly correlated with one another, and now we need to find their correlation with the target variable. So the first one is 0.16, the second one is 0.09, 0.13, and 0.17. So which one do you think we should keep?
Vehicle claim.
So no, it's vehicle claim.
It's the most correlated with the target variable.
Because it's 0.17. Total claim is 0.16. This one is 0.17.
What means?
means
It's the top.
no, vehicle claim is is highly correlated, has a strong correlation with the target variable than the total claim, than the engineer claim, than property claim. Okay, so we are going to keep the vehicle claim, the last one. We need to keep vehicle claim. So now we are going to remove age after we consult with our expert. We need to remove also the total claim, engineer claim, property claim, and we need to remove our year because it's very small. It has small correlation with target variable, and we also need to remove the number of the incident hour of the day. Okay. So we need to remove. We need to remove any one of these two and any one of these four. I'm sorry. We need to remove one out of these two and one of these four. Which one we need to keep? We are going to keep the one that have a strong correlation with the target variable. Are you guys clear? So let me read the question for Aisha. Aisha said, sir, in the example you specified the correlation person. How do we choose? Again, when do we need to choose the spearman, the person, and Kendall? So this type, it totally depends on the type of correlation you are looking for. I will not bother myself on which correlation to choose. These three correlations, they are going to give you a value between -1 and 1. Of course, some of them, they are going to give you a different value. But if you are working on a sensitive projects, as a project that is not related to human lives, then I really don't care which correlation you are using. If you are working on auto insurance, you are working on bank customer churn, you are working on anything that not related to humans, I really don't care which correlation you are going to get. They are going to be the same, very close, but the same information. But if you are working on a very, very sensitive, then you need to determine which, based on the sensitivity of that project, which feature, which type of correlation that you need to use. So let me give you an example. Yeah, I'm going to give you an example. Okay, I am going to create one feature, and we are going to name it Morocco. Just for training purpose, Morocco. Okay, and the value for Morocco is going to be the value of age to the power of 3. Okay. So if I were to ask you about age and Morocco, if I were to ask you a value between age and Morocco, are they correlated? No. The question is, are they similar?
No.
Of course no, because we have this age, we have this Morocco, we got 48, we got 1100,000, so they are not similar.
Similar, yes.
They are not.
No normal distributed, maybe.
No, I'm not talking about that, brother.
No?
I'm not talking about that. I'm simply talking about the name of the feature and the value of each feature. Age is not Morocco, Morocco is not age, and the value for age are not the value of Morocco. So it looks like they are not similar. But let's read the data. Yeah, let's read the data again, and I'll show you something very important. Yeah, I'm going to read the same data. Okay. Okay, got it. And now we are gonna fix the names, and we are gonna go all the way to the correlation analysis. Let's find out. We know that Morocco and age, they are not similar, name-wise and also value-wise. The value of age, they are not the same as value of Morocco, and the name of the feature name, which is age, is totally different than Morocco. So you can tell they are totally two different features. But that is not the reality. That is not true. Let's find out using the correlation analysis. So again, in terms of correlation analysis, we are gonna keep between x, let's say that's xb, x1 and x2. We are gonna keep one of them if their correlation is closer to 0. If their correlation is closer to 1 or closer to -1, we need to remove one of them. Which one to remove? Then we are going to look for age versus target variable, and also we are going to look for Morocco versus target variable. So let's find this the first one first. So we are going to do correlation. So we got age, and we got Morocco is 96%. Is 97. So simply means the information we have in age are the same information that we have in Morocco, even though Morocco has different values and age are different values, and they are not. You cannot even think about any correlation if you were to look into the data physically. من كتشوف هذه البيانات مستحيل تعرف بأن راه كاين واحد العلاقة ما بين age and Morocco، لأن الأسماء كتختلف وحتى الأرقام كتختلف، يعني مستحيل تقول لي راه كاين واحد العلاقة بيناتهم. لكن منين درنا correlation they are very strong. There is a very strong correlation. إلا درنا سبيرمان، يعني هذا الرقم يقدر يكون هذا الرقم هذا يقدر يطلع حتى لواحد. You see, age and Morocco is 1. Means they are 100%, they are the same. So age and Morocco 100% they are the same. إذا كان 100% they are the same, then we definitely need to remove one. الا بدلنا الميثود من سبيرمان لكيندال غادي نلقى حتى هو رقم كيندال لكن قريب يقدر يكون قريب لواحد. So maybe I spelled it wrong. Yes, yeah, I mean yes, it is gonna work, but the Kindle it takes it's a lot of correlation, a lot of math behind the scene, and it might throw an error. Yeah. Anyway, we are gonna keep. Is it? I think I spelled it. I misspelled it. Anyways, let's keep the experiment. And Spearman versus Pearson versus yeah, it's a double L Kindle. Yeah, that article كي بين لك العلاقة ما بين هذا the difference between these three. Just some research. Some research. Of course, you are gonna educate yourself on difference between this type of correlation. لكن ما كيهمش إلا ما كنتيش خدام في شي sensitive project. It really does not matter which one you are using. And correlation type when to use them. Yeah, this is a very good article. I'm gonna share it with you guys in the chat. Please go through it, educate yourself. Okay, Aisha, are you clear? Yes, thank you. Ilmad is double L. Thank you. Aisha, are you clear? Okay, good. Okay, so now we need to remove the Morocco. Let's remove Morocco. Yeah, we could do that. Okay, and yeah, Morocco is gone. Good. Okay, so scar plot here it does tell you two things. The scar plot is used for numerical data, number one, and it does tell you if there is any relationship between your axis and the direction اتجاه. So this is only one. You could do so this is a correlation between month as a customer's age, and you can tell they are moving. Of course, we got some problems at the early beginning, but they are both of them, they are moving in the same direction. So that's simply this is another evidence that we have to remove one of them. Okay, I'm going to skip. I'm going to show you there is one library. It's called profile. It's called pandas profiling. So let's install it first. And this pandas profiling, what it does provide you statistical analysis, data visualization for all your features right with one click. And there are there are many libraries. This is the pandas profiling, and this is a suite viz. Yeah, let me I need to install the suite viz. Ah, misspelled it. It's V's with Z, not X. Anyway, we'll come to it. So the pandas profiling still got installed. Come here, come here, come here, come here. Yeah, say hello. Say hello. Hi, Moroccans. This is my cat. Okay, so it's still downloading. So we got to give it a few minutes. Here we go. And we are gonna do install this also through the prompt. Okay, so a few more minutes, then we should have this. It's a beautiful report. Here we go. It's done. Okay, run it again. Now we are going to import the pandas profile. Playing with my cat. Come here, come here. Sorry guys. Abduladim, correlation, the person, I have no idea, brother, what you're talking about. I don't speak French. So please forgive my ignorance. I do not speak French. Yes, Mehdi, that is true. This correlation, they measure different things. Some of them, they measure the association. Some of them measures the linearity. They measure different things. But at the end of the day, you are going to get a value between -1 and 1. And if you are using very sensitive, if you are working on very sensitive projects, then you need to determine which one best fit you. Otherwise, we don't care. All I care about is give me a value. So it's still building the visualization, and oh man, it's 33%. Okay, so while this is working, let's move into the topic of today. Topic of today is going to be machine learning. It's going to be data preprocessing. So in data preprocessing, a few things that we need to look at. Few things. And this would create some problems, some serious problems, if they are not covered properly. So number one, we need to look for missing values. Missing values. We need to look for duplicates and low variation data. Incorrect irrelevant data, like the one that we just had. We got Morocco and we got age. Morocco is not related to insurance, so simply we are going to remove Morocco, either with or without having any correlation. When we looked into the features, and we saw that there is a feature that is not related. Of course, we got age, month, and we got this Morocco. Where this Morocco is coming from, we don't really know. It's not related to our insurance. I am simply gonna remove it. Regardless, I'm gonna remove it. I don't care if it has value, but it's not related to the domain is not related to the topic, unless this data is from Morocco. Then definitely we can determine if we can keep it or not. We are not going to keep it. But when you look into the features, if you find a feature that is not related to the problem the problem you have at hand that you're trying to solve, that is irrelevant. I'm going to simply remove it. So we need to look for categorical data. In categorical data, we need to know if it's nominal or ordinal, outliers, feature scaling. Later we are going to learn how to scale the features and why. Feature engineering, this is very important. We already covered few things about the feature engineering, how to eliminate some features using knowledge base, and also how to eliminate some features using the correlation analysis. So far we learned two techniques to help us reduce the elements in the data, and later we are going to learn probably some techniques how to extract, create new features. So this is something, and later we are going to talk about data validation split. Okay, so let's go to the lecture, to the presentation. But before I do that, let's take a look into our course to see if everything if it's complete. No, it's still 100%. It's still generating the report. So it is going to take a while, but you are going to be surprised by the amount of information this pandas profiling is capable of providing, and also the amount of information this suite views will provide. So let me random very quick. And so we are going to create some HTML reports. Okay, so now let's move on with that. Again, you are working for the same business problem as data scientists. The first thing we did is we determined the methodology, and we agreed to use CRISP-DM. So CRISP-DM is all phased. The first phase is phase number 1, which is business understanding, and working with the expert, with the domain expert to gather the requirement. Then we moved into data understanding, applying expert data analysis, data visualization, statistical analysis. At the end of this phase, we should have a quality book. A quality book is simply a document where you have everything you discovered on your data, everything from the technical standpoint. So you need to document anything related to the quality. So you need to document outliers, missing values, outliers, missing values, irrelevant, incorrect data, duplicate records, categorical data, etc. So you need to touch base most of these things in that report. And that is the report we are going to use to fix the quality issues. So this is a typical quality report. Your report should not look like this exactly, but it has, in the report you have to document everything that you discovered during data understanding phase, and that is the roadmap that you are going to use later to fix in your fix. So we need to fix the target variable if it's not balanced for categorical, binary, trinary, multi-class, and if it's not normally distributed for continuous, we need to fix it. We need to fix the redundant and duplicates. We need to deal with missing values, with outliers, with the data with high cardinality, Then we need to deal with categorical data. Then we need to transform numerical data. We need to, please, everybody, please mute yourself. Thank you. Then we need to learn how to normalize, factorize, binarize, standardize. We just talked about correlation analysis. We are not doing data decomposition because it's related to time series. But out of this, you don't have to do everything that you see in this graph. And by the way, this is not an exhausted list of what needs to be done. هذه ماشي اللائحة النهائية ديال جميع تطبيقات وجميع processes that you need to apply on your data. It's not. But just choose whatever works best. Whatever you think is going to work better for your data. كاين جوج الحوايج انا اللي سطرتهم بالحمر. Feature engineering and feature selection. هادو they are the most important steps in data preparation. Okay. And first, when we started with we collected what we call the raw data. بدينا بال ABT. حولنا داك ال ABT للفيتشرز. وهنا بدينا بالرو داتا. raw data هي المادة الخامة. data, but it's a raw data. It's not yet. It's not good enough yet. It's not ready yet for the analysis. ومنين درنا قاعد المسائل هادو. Now we have a better version. And not version number 2 or version number 3. So this is what this is the data we are going to use for that, not this one. This one is a raw. We need to explore it, visualize it, apply some statistical analysis, find and document everything we explored in regards to its quality. Then pre-process that quality, and now we are going to have a better version of this data, and that is the version we are going to use later for the modeling. We cannot use this data into the modeling. We have because of the garbage that data could have. So this data is more suitable for the modeling, for the analysis, for the machine learning, rather than using the raw data. Okay, so few things. Data is always dirty regardless, so we need to look for incomplete data, noisy data, inconsistent data, unintentional data. I'm going to skip some of this. Okay, so this is major task. So these are the major tasks as data scientist or that you need to apply. Number one, always good to reduce the dimensionality of the data through aggregation. For example, you have a data. This is sales. عندك بيانات حل المبيعات. عندك مبيعات ديال يناير فبراير مارس January February March April all the way. So instead of using 12 months, 12 columns, we are going to simply use one column and we are going to name it total sales. وغادي نجمع فيها كاع جميع المبيعات ديال العام ونديرهم في column واحد. Instead of having 12 features, no, we are going to have only one feature, and that is called aggregation. Then samplings always have to use sampling, and there are two types of sampling: probabilistic sampling and non-probabilistic sampling. The non-probabilistic sampling نعطيها بتسع. They are not good. They are not used. They are not good for analysis. And under probabilistic sampling, then we have simple random sampling, stratified sampling, cluster sampling. There are many different types of sampling, so you need to determine which sample to use. Dimensionality reduction, you could use feature engineering or feature selection. In feature selections, we already learned how to use a knowledge base and correlation analysis. And of course, in the 30-week program, we are going to learn more than 12 type of methods that we could use to reduce the dimensionality. Feature subset is always good to take. Is similar to the sampling. You take a subset in terms of not only the variables, but in terms not only the records, but the variables as well. Feature creation, discretization. Sometimes you are going to have a value like yes and no. Transform it to 0 and 1. Attribute transformation. If your data is not normally distributed, then we need to normalize it, or transform it into Gaussian bill shape. These are few things that you need to apply to your data to bring it to a new version. Okay, so let's go back now to go to our here we go, our codes. So we got the report. Excuse me. So what do we have? Yeah, this is a very good quality report. So we got 40 variables. We got 1,000 excuse me, records. We got missing values is 0%. Missing cells, we got no missing cells. Duplicates, we got 0. Duplicates, we got 0. Then we got how big the data is. We got 14 numeric, 25 categorical, and we got one what you call it, the binary, and that is target variable. Excuse me. In terms of variables, so these are all the variables that we have, and we got month as a customer, and we got some statistical analysis, missing, infinite percentage, and we got the distribution. You need more details? Yes, let's do that. Okay, we'll talk about the standard deviation, the curtices, the correlation, the 5-number summary, the first quantile, the third quantile, the median, the range. Skewness is 0.36. This is very high. The best skewness is 0. Okay, interaction. So this is how these values are interacted to one another. This is the correlation. Again, it's similar to the one that we covered. Missing values, there is no missing values. So it's really beautiful reports that it is at your fingerprint. Without, you don't need to go through whatever we covered in explored data analysis. This pandas profiling should be enough to provide you any information you need on any feature of your data. Okay, it's really, I really like it. It's brilliant, and it provides information you are gonna need. So you got zip code, you got some missing in there. Okay, so let's take a look now into the other report overview. Okay, what says here? Yeah, this is a problem. Sweet V. Yeah, probably the library is not compatible. Yeah, let's run it again. But do you guys have any question? Yeah, let's read the questions again, and we'll stop here. Yeah, that is true, Imran. Yes, in Google Colab, yeah, you can do that. And there are other platforms that you could use. One of the platforms that I really like, and we are using it, is called Einblick. Einblick. And it does help you to visualize. It does help you to visualize the how the codes are actually working behind the scene. It's called Einblick, and simply sign in. I have a very strong relationship with the owner of this this website, this tool. Luckily, they provide us with free licenses for my students. 1 year free license or 8 months free license. So this is another platform that you could use. Quality book. Yeah, this is a quality book. Yeah, the one that I just shared with you. That is an example of a quality book, and this is another example. Yeah, this is a quality book. Sorry, it's still loaded. Here we go. Yeah, this is a quality book. Okay, this is a very good quality book. It has all the information you need about your data. Okay, this is still running, but let's take a look into it tomorrow. So, any questions, concerns about this? Any questions, concerns? Any, please? Okay, folks, that's it for tonight. For today. I'll see you guys tomorrow. Tomorrow we are going to move into learning about the quality of the data.
Sir, please.
Yes, sir.
I'm asking about how can get a free license for
Just
behavior.
yeah, just create an account with them.
Okay. And we get 1 year
No,
free
no.
license.
That is 1 year is
okay.
for my student, for my official students.
Okay.
Not
Thank you.
for the free program, unfortunately.
Okay. Thank you.
Yeah, welcome. Okay, folks, that's it for today. I'll see you guys tomorrow. Until then, you guys have a great morning. Here we go, guys. So this is the before I dismiss you, this is the
Quality report.
no, yeah, this is the second one. This is the second library.
Okay.
Yeah, let's do this. Okay, I think I lost it. Okay, this is the SweetViz library. You see, that's everything, anything that you want to learn about your data. And then you could use this as a quality report.
Okay, thank you, sir.
Okay, folks, that's it for tonight. I'll see you guys tomorrow. Assalamu alaikum wa rahmatullah.
Salam. Thank you.
Thank you. Bye bye.
Thank you very much, sir.
Thank you.
Recording stopped.